Welcome, I am Shemus. I will make a presentation about REST API. The topics I will talk about will be API, web services, REST, RESTful concepts, HTTP methods, and documentation. First of all, before moving on the concept of REST, let's look at what API and web services are. What's API? API stands for Application Programming Interface. It's a set of rules and specifications used to communicate between two software applications. API allows two software programs to communicate with each other. One program can call another program's API to get access to data or functionality of the other program. How an API works. We can explain how the API works with the restaurant analogy. A common analogy to describe an API is a waiter in a restaurant. When you go to a restaurant, you interact with the waiter in order to get the services offered by the restaurant. You can order food and drinks, ask questions about the menu, request and pay the bill. In this analogy, the waiter shields you from all the complicated stuff that happens behind the scenes. You don't have to worry about receipts, cook, calculating the bill, or serving food and drinks, etc. The waiter is the interface between you, the customer, and all of the restaurant services. The waiter provides a way for you to interact with the restaurant without bothering yourself with all the complex process happening in the restaurant. Through this waiter analogy, you can intuitively understand the use and importance of the APIs. If we give an example to the API, we can buy a flight ticket on different websites. For example, we can buy a ticket on both Enuygun, Ucuzabilet, and obilet.com. This is possible thanks to the flight providers' APIs that offers airline ticket data. What are web services? Web services are standardized methods for interoperating between different software applications running on different platforms, programming languages, and frameworks over network. We use various programming platforms to develop web-based applications. Some applications may be developed with Java, ASP.NET, PHP, Node.js, and so on. With using different languages and platforms, it becomes difficult to ensure accurate communication between applications. This is where web services comes in. Provide a common platform that allows multiple applications built on various programming languages to give the ability of communicate with each other. There are two types of web services. First one is SOAP, that stands for Simple Object Access Protocol. This is a protocol that uses XML as a format to transfer data. The second one is RESTful. We'll focus on RESTful web services, and RESTful web services get their names from REST architecture. Now that we know what APIs and web services are, we can move on to the concept of REST. REST stands for Representational State Transfer. Introduced by Roy Fielding in 2000, REST is an architectural style that basically exploits the existing technology and protocols of the web. It's a set of rules that developers follow when they create an API. It's based on HTTP protocol and data transfer with JSON or XML format. REST architecture is built on several fundamental principles. In REST, the primary data representation is called resource. Any information that can be named can be a resource, a document, or image. Each resource is identified by URI. For example, /users returns collection of users, /users with an user ID returns a specific user. Having a consistent REST resource naming strategy will provide one of the best design decisions in the long term. Another principle is client-server architecture. The client and server operate independently. The client accesses server resources, but there is no tight coupling between the client and the server. The client doesn't know any backend implementation details like which database is being used, which programming language is being used. All it needs to know is how to invoke the API services exposed by the server. Similarly, the server doesn't know any front-end implementation details like whether the client is using React.js, Vue.js, or Angular, or pure JavaScript for rendering the user interface. Whenever possible, API implementation should instruct the client to cache the API response for future API requests. The client can use the cached data instead of invoking the API service again. Response must be explicitly marked as cacheable or non-cacheable. HTTP response headers indicate whether a response can be cached with cache control, HTTP header, e-tag, and last modified headers. This response is received after requesting to the GitHub. You can see that there is a HTTP header cache control. It says public, it means the response will be cached. Max age is 60, it means the response will be cached for 60 seconds. And the last modifies gives information about when was this response is received as fresh. API server must not store any information about the client session state for receiving future API requests and must treat every client request as new. This constraint simplifies the API implementation and also improves scalability. The client is unaware of whether it's directly connected to the end server or with an intermediary like proxy. From the client's perspective, it's connected directly with the end server and has no knowledge of the intermediaries along the way, like proxies and gateways. Also, each layer is only aware of the existence of the next layer and not of the layers beyond that. This layer structure improves system security and scalability. Now we will move on with RESTful API benefits. Semantic naming in RESTful APIs refers to using clear and descriptive names for endpoints and resources. This practice enhances the readability and intuitiveness of the API. For example, instead of using generic names like get users, RESTful APIs use more descriptive names like users/users for retrieving a list of users. Semantic naming follows standard conventions, making it easier for developers to understand and use the API without extensive documentation. Of course, we will prepare documentations. Relational endpoints enable easy navigation and access to related resources, promoting better data organization and clarity. The first endpoint retrieves all orders for a specific users. URL includes users and orders with a specific user ID. And the second one retrieves all reviews for a specific product. And URL includes reviews, products, and with a specific product ID. In RESTful APIs, separating request data from the entity model is a best practice. The model on the left side is our request model sent by the client. In this model, there is an ID section specifies the data to be updated in the database and the fields we allow to be updated, first name and last name. On the right side, we have our user entity and we have two more fields like email and username, and the client cannot be update these fields. Creating request models for the function to be performed will increase the security within the application. For example, if we don't want a client can be update its email address, we shouldn't put email field in our request model also. And standardizing responses helps clients easily parse and handle API responses. A common response model defines a standard structure for API responses, promoting consistency. This typically includes a status, a message, and the data payload. For example, this response is in a success status. Message says user retrieved successfully, and we have data and user data. This is possibly a get user request to the server. And we must ensure that incoming requests meet predefined criteria before processing. This validation can include checking for required fields, data types, value range, and business rules. For example, we have an example user registration request. and the response says status false, message the request is invalid, and also gives detailed information about errors, says the email field is in invalid format. And let's give some information about the components of RESTful APIs. Some of the primary components are headers, data, methods, and endpoints. Headers, with the help of the HTTP headers like authorization, content type, and cache control, RESTful APIs manage their informations. And authorization headers determines which users can access which resources. Role-based access control is a common method for this. And content type specifies the type of message to be sent in data. And cache control headers, we already mentioned cache control. It determines whether clients should cache this response or not. Data is the body that contains information on the client requested resource. When a client determines the content type of header in the header, the body contains the actual content. For example, if a content type is JSON, and data should be in a JSON format. If an XML, it should be an XML format. And methods, APIs manipulate data by using certain HTTP methods like delete, post, put, patch, and get. And endpoints, these are URLs that defines the data location on the server. For example, get users, it's get list of users. It's a location of the user. A user's collection. Endpoints are basically the resource and location of the resource that we try to access with an API. One of the most critical aspects of developing and maintaining RESTful API is true and clear documentation. Proper documentation ensures that your API is easily understandable and usable by other developers, whether they are not part of your team or external users. One of the best tools available for API documentation is Swagger. Swagger is an open source software framework. It has tools that helps developers to design, build, document, and consume RESTful web services. You can also use Postman to test your API, to document your API, and also create a request flow of your API. I want to do some examples, some request examples to the JSON placeholder public API. I have an JSON placeholder collection. This consists of get posts, get a specific post, and create delete update post, and get and specific get comments of a specific post. Let's try this get post endpoint. You remember we mentioned about what's endpoint. Endpoint is a data source, or actually resource location of and data or collection of data in API in server. When I click send, it gives me some a collection of posts, you can see, and this request actually this, when I put one at the end of this endpoint, it will give me a single post object because I give an ID at the end of this endpoint. And also you remember we mentioned about, we talk about relational endpoints. What this endpoint does, this endpoint returns comments of an specific post, right? And let's try. You can see that there is a collection of comments. It belongs to a post that that's ID is 1. And also we can create a post with that belongs to user ID equals 1. Let's try, and you can see a new ID is assigned by the JSON placeholder API, and we have a new post, and we can delete posts with the same endpoint with different HTTP tag, HTTP method actually, and actually this is the same endpoint with this, and only difference is HTTP method type. And when I click send, the response is null because the post is now deleted. And let's talk about differences between put HTTP method and patch HTTP method. The put HTTP method is actually, the patch HTTP method is a partial update. For example, if I delete the last 5 words and click send, it will return this object, right? But if I delete this body portion and click send, the body portion didn't affect this request, right? Because I use patch HTTP method. If I use HTTP put HTTP method and delete this body portion, it will automatically set to null the body portion, because the update requests that are requested with made with HTTP put method will affect the whole object.